Okay, good evening my dear students. Today I have come to take a class on calorimetry, which is in class 10 ICSE. It's a very important chapter and very easy to score marks in ICSE board. Just carefully listen to me, whatever I say, and try to understand briefly. तो मैं ये पहले कहना चाहता हूँ कि कैलोरीमेट्री समझने से पहले हमको हीट के बारे में जानना बहुत जरूरी है। हम बचपन से ही पढ़ रहे हैं कि हीट किसे कहते हैं। कोई कहता है कि हीट एक फॉर्म ऑफ एनर्जी है, सही कहता है, लेकिन ये सब छोटे छोटे क्लासों में ही ये सब समझाया जा सकता है। एक्चुअली व्हाट वी से इज हीट. So everyone says that heat is a form of energy. Yes, even I know that heat is a form of energy. But to demonstrate what is heat, we have to go to the concept of class 3 and 4 regarding the molecules of a matter. We know that whatever the state may be, the matter, then what happens? Every molecule is in random motion. Since the molecules are in random motion, that means we must know that they are possessing kinetic energy. Again, the molecules, every molecule gets attracted or gets repulsed. So when they get attracted, that means what? They are having potential energy. So these are the two energies which you can sum it up and can say it is the internal energy of a molecule. Then what happens in a state of matter? The in total sum of internal energy, it constitutes the heat energy. So we can say what is the heat energy? It is the total internal energy constituting by molecules in a state of matter. Now everyone knows that any energy can be measured in SI unit as joules, which is, we can go with the symbol this joules. But the other unit of energy is also calorie. So when anyone asks you to define calorie, so we generally say calorie is the measure of energy. 1 calorie can be defined as the amount of energy, heat energy required to raise the temperature of water by 1 degree Celsius. My dear, we should not say here 1 degree Celsius. Why? Because already we have learned in the earlier class that water maintains anonymous expansion. That is, there is non-uniform expansion in water molecules. Hence, so the perfect answer should be to raise the temperature, heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius. Here from 14.5 degrees Celsius to 15.5 degrees Celsius, you have to mention this clearly to get your answer correct, or else you won't be getting any marks in your examination. Next, we can come to the another topic, that sometimes we say that we give heat energy to a body and the temperature rises. It's not true always. Why? Because sometimes you give heat energy, but still the temperature of the body doesn't rise. Suppose if you give heat energy to your eyes, okay, but the ice at 0 degree, unless it melts at 0 degree in water, we are giving heat energy, but there is no rise of temperature. So this is the other part of your chapter. So first let us go with one more explanation in which we can say that to raise the temperature of any body, we have to give heat energy. Then how it is related to raise a body through certain degree, how much heat energy we have to provide. Let us calculate that one. Very first thing, let us represent the heat energy with Q. Now, number 1, what happens? Suppose you have two masses. Okay, one of the masses of the same matter. That means the molecules remains the same in both the cases. Suppose in one matter, Suppose in one case the weight of that substance be 1 kg, and with the same matter another substance be 2 kg. Then to raise the temperature by 1 degree Celsius, okay, naturally suppose some X heat energy is supplied and here Y heat energy is supplied. Why both the difference? Because for 1 kg to raise the temperature through 1 degree Celsius, X energy is required and here Y energy required. Naturally X must be less than Y. That means what we have understood from this, that if the molecules are same of any two substances but the mass differs, that means heat energy is also differed to raise the temperature of the body through 1 degree Celsius. That means one thing we can say, that heat energy is directly proportional to the mass of the substance. Again, number 2, we can say that, again we are taking this one more example. Suppose we are taking two substances of same masses. Okay, so that let us say that the two substances be water. Suppose this is 1 kg water. Another bottle is also there, 1 kg. Now, to raise the temperature of this bottle of water by 2 degree and this by 1 degree, so naturally to raise the water of the very first bottle through 1 degree requires much less energy to raise the same mass of water through 2 degree through 2 degree. So that means what? Again we can say that the heat energy is directly proportional to change in temperature. Also one more factor is there. Suppose the masses are same, the temperatures are through 1 degree Celsius, but there matters that if the substance is not made up of same matter. Suppose we take two different matter. Number 1, if we take copper, and number 2, if we take iron. The masses are same. Okay, 1 degree we have to raise the temperature, but heat energy required to change in 1 degree in copper will be much less than the heat energy required to change through 1 degree in case of iron. That means what? Again the substance also matter. That means heat energy is also directly proportional to the substance of the matter. So so we have got 3 different factors. So from 3 different factors we can conclude one result. That result is, number 1, what we have learned, Q is directly proportional to mass of the substance. This is number 1. Q is proportional to change in temperature of the substance. This is number 2. So from 1 and 2 we can conclude that Q is directly proportional to M del T, where this is del T means change in temperature. So Q is proportional to M del T. If you take out the sign of proportionality, then you must multiply with some constant. Let that constant be C. So Q is equals to M into C into del T. This is the constant of proportionality, which can be also, which we can say is a specific heat capacity. Okay, so this is one more derivation. Often it is this derivation often you can get in your examination, and also in board examination they give certain type of derivation. So let us go with next one more question. Let us go with some numerical problems regarding this derivation.